So okay, we will see directly the first method, that is Jacobi method. So this is a simple method we need to understood. So earlier methods were direct method that we need to know. Now here our methods would be indirect. So first we'll see Gauss-Jacobi and Gauss-Seidel. Gauss-Jacobi method we are using. So first we have to represent the given linear equation. So whatever the linear equation said, that we have to represent. Suppose this is the equation a1x, b1y, c1z is equal to d1, a2x, b2y, c2z is equal to d2. A3x, B3y, C3z is equal to B3. This is a given set of linear equation, and we need to derive a certain formula by using Gauss-Jacobi or the simple Jacobi method. What we have to do is we have to use the first equation for the x value. So we have to represent given equation in the format of x is equal to. Second equation in the format of y is equal to, and third equation as z is equal to. That we need to represent, and initially we have to guess. Initially these three equations we have to create the first part, then second part would be we have to assume certain values. We have to assume certain values of x, y, z, and this assumption value we have to put in this equation, and we have to do a next level of x, y, z value. That would be called as x1, y1, z1, or whatever the different structure you give, that depend on you. So next level of x, y, z we got. Then again we have to put this x, y, z value again in this equation, get the x2, y2, z2. This way we have to continue. It could be 8 iteration, 9 iteration, means 9 times we have to calculate, 10 times maybe you have to calculate. So this would be called as a iteration. This would be called as a single iteration. And then when we have to stop, so obviously I have said 8 times, 9 times, we have to stop until at least 3 decimal point would be same. Then only it would be appropriate to stop. Means we can say this appropriate solution we have achieved. So this is the criteria of the thing where we need to stop. Okay. So first thing we need to do is we have to create equation. Whenever this kind of equation is given, we need to convert in the format of x, y, z. In the format of x, y, z. So x is equal to, if you see the first equation, x is equal to, that would be d1 minus b1y minus c1z and divide by 1 upon a1. 1 upon a1. That would be the equation for the x. Then we have to see this particular part, and we have to convert into the remaining part. So that would be d2 minus a2x, and then minus c2z divided by 1 upon b2. Same way, the last equation will be this. We have to convert into the equation for the z value. Z value. Z is equal to d3 minus a3x and b3y. So obviously, if these two terms go on this particular right side, then definitely the sign is going to change. Okay, that's why I am writing here minus. And 1 upon that was a3. Here c3z was there. So c3z we have taken z common. So obviously that value would be 1 upon c3. So this equation we going to create by simple exchange of terms in the terms of x, y, z. So we need to create this kind of three equations. And next step would be simple, that we have to assume this basically d1 that value would be given. We need to assume this kind of value of B, Z, X, Z, X, Y. So we have to assume initial value X0, Y would be again 0, and Z would be, we have to put as a 0. And then we have to calculate this X1, Y1, Z1. Then again we have to calculate X2, Y2, Z2, X3, Y3, Y3, Z3. Means this format of equation we need to repeat again and again. This is the simplest thing we have to do. Whatever the equation given in for the linear solving by using the Gauss-Jacobi method, we have to create this kind of equation. This is the only part we need to do. So obviously, if you want to don't want to confuse, right here x1, y1, z1, and these values will be y0. That means initial values, whatever the values given in the particular equation, x0, y0, z0, y0. Here again it will be x0. Initial value, and we have to assume initial x0, y0, and z0 as a 0. We have to assume you have to start from anything. You can start from any point. If you know the range of the particular solution, then we can take a halfway mark also. Depending on the situation and depending whether you know the range of this x, y, z, then we can start random value also. It should be somewhat near. If you don't know the range, you can start with the 0 also. Okay, so most of the time we are going to start with the 0 and take next we have to do a iteration, calculate x1, y1, z1, then again calculate x2, y2, z2 by putting the previous value. So whenever we are going to calculate x2, y2, z2, that would be here x1, x1, z1, y1, z1. This kind of situation would be there. So these are the new values. These are the new values, and these are the older values. Older iteration. These are the values that we got during iteration. Okay, so this is called as a Gauss-Jacobi method. Whatever the difference, I will explain here itself. Gauss-Seidel method. In a Gauss-Seidel method, same equation would be there, but only difference we need to create in the equation number 2 and 3. Whatever the equation we have created in the equation number 1, that would be same. So this would be x1 is equal to, we are going to see here, Gauss-Seidel method. This is a Gauss-Jacobi or Gauss-Jacobi. Yeah, simply you can say Jacobi method. This is Jacobi and this is a Gauss-Seidel. The first equation will be same. Whatever the linear equation will be given this, and we have to convert again the same x1, y1, z1, but there is a slight difference we need to create. Only one slight difference we have to create that we should know while we are going to solve equation by the Gauss-Seidel method. So that difference, the first equation would be same, 1 upon a1 d1 minus b1 y0 minus c1 z0. Then here we need to calculate y1 value. Right, the here we are going to assume this value as x0, but in the previous equation we have got the x1 value. We have got the x1 value. So only difference we have to create is in the second and third equation. In the second equation, we need to create a d2 minus a2 x1. I will make this part as a dark x1 minus c2 z0, because z0 is also don't know. So now last equation z1. So z1 is equal to, now here you can see this equation. Whenever we are going to create the z1 equation, already we know the x1 and y1 value. So instead of x0, y0 value, we have to change in a z1 value. So z1 is equal to 1 upon c3. Sorry, 1 upon c3 is correct. Minus d3 minus a2 x1 minus b3 y1. Okay, so same part with the equation we need to create. Again, next level x2, y2, z2 we need to calculate. X2, y2, z2, that would be depend on, first we use this x1, y1 here for calculation of y1. Sorry, y2 we need to calculate use x2 value and z1 value. Same way for z2 value we have to use x2, y2 value, because these values are already calculated, so we can put in this equation. Here that concept we are not considered, and directly x0, z0. So initial values all there, everything, every equation we have taken first part previous year values. So then no changes were done in equation number 2 and 3. So here equation 2 and equation 3 were changed in a Gauss-Seidel method. Okay, so write down this particular formula and we will take a few problems on this particular Gauss-Jacobi and Gauss-Seidel method. Obviously, there is some issue also, that one of the most important issues is that largest coefficient should be at the, there should be a largest coefficient at each equation. There should be a single largest coefficient should be there in each equation. Each equation of the system must have a one largest coefficient, and largest coefficient must be attached to a different unknown. Largest coefficient should be attached to the different unknown. Once it should be x1, then there should be it should be attached to b2 and it could be attached to c3. Means if one largest value in a first equation is attached to x, then it should be in a y in the second equation, and third, if it is a z value we have to consider, then z value coefficient should be largest. And the second formula or second assumption is that diagonal elements should be the diagonal elements, whatever the a1, b2 and c3, a1, b2, c3, a1, b2, c3, these are the diagonal elements. Their coefficient must be greater than remaining two. Their diagonal elements matrix, coefficient matrix must be greater than summation of remaining elements. So this were assumption we need to do. इथे काय पाहिजे, हे जे इक्वेशन दिलेले आहे मोस्टली काय पाहिजे, a1 ला जर लार्जेस्ट व्हॅल्यू असेल तर b2 ला लार्जेस्ट पाहिजे आणि c3 ला लार्जेस्ट पाहिजे. हे जर डायगोनल एलिमेंट जर लार्जेस्ट असतील, इफ सपोज वी नीड टू अरेंज दिस वे that a1 should be at the largest, b should be at the second largest, and c3 will be third largest. Means the value of c3 should be larger than a3 and b3. b2 should be larger than a2 and c2, and a1 value should be greater than b1 and c1, and also a1 should be greater than summation of b1 plus c1, b2 should be greater than a2 plus c2, and c3 should be also greater than a3 plus b3. That assumption we need to consider while solving this kind of equation. So write down this equation, take a few minutes, read out the formulas. We'll take a problems based on this equation. This is one of the simplest, everybody should solve. And if this kind of question is asked in examination, definitely you should get 8 marks. Take a few minutes, 5 to 10 minutes maybe, and read out the formula, read out the procedure, see the procedure on the blackboard, and we'll get a few problems based on these methods. Have you written this particular formula? If you have written this particular formula, type yes, so that I can see how many people are alive here. You have written the formula, type yes. Yes, yes, 3, 4, 5 people are there. Very good. Sandeep, Pooja, Akash, Shubham, Kar, Sandeep, Akash. There are a lot of people. More than expected people are there. We have typed yes. Take a problem. Simple problem we are going to take. Though there would be a lot of iteration would be there. Maybe 8, 9 iteration would be there. So we'll take a problem. We'll solve by using was. And the equation x is equal to minus 5y minus 2z is equal to 3. 4x minus 10y plus 3z is equal to minus 3. 6y plus 10z minus 3. Solve this equation by using Gauss-Jacobi method up to 3 decimal points. So this is the problem. 3 decimal points they are purposefully given. In the problem itself, they are mentioned we have to solve 3 decimal points. That means we have to take whatever the 4 decimal points, 5 decimal points we have to take, so that automatically minimum 3 decimal points should be will come same, and all diagonal elements should be dominating. You can see by default all diagonal elements are dominating. Again, the 10x value is a absolute value we have to consider, that is greater than 5 plus 2. So minus 5 minus 2, that could be a minus 7, but it is a greater. So we have to absolutely we have to consider the signs. Then here the 10 value, here 10 value is also greater than 4 plus 3, 7. So apart from this 2 and 3, 7, that is also greater. 1 plus 6, 7, again it is a greater. So by default, this solution we can obtain by using this kind of iterative methods. Simple iterative methods we can use. So the first step is that we need to create this equation. We need to create for the x, y, z values. So first equation is x is equal to 3 plus 5y plus 2z divided by 1 upon 10. So we have converted this equation in a format of x. Then again, we need to write the equation in the format. We have to create equation for y from the equation number 2. So y is equal to, so minus 3 minus 4x plus 10y, sorry, not 10y, plus minus 3z, 1 upon 10. This is minus sign, so we have to consider this is a minus 1 upon 10. Or we have to consider this equation as a 10y here, and this terms are should be, you can get this as a 1 upon 10 4x plus 3z plus 3 and 1 upon 10. So we can create this kind of equation also. Z is equal to minus 3 minus x minus 6y upon 1 upon 10. 1 upon 10. So this equation can be utilized for the value of j. So now the first step is over. Now second step, that we have to assume this x, y value, x0, y0 and z0, and calculate the value of x1, y1, z1. So if you put this particular values x0, y0, z0, it would be 3 by 10. I don't have a calculator. You should write exact points. 3 upon 10. Yes, it is a 3 upon 10. And this also 3 upon 10. So 0.3, 0.3, 0.3. Now put these values, what we have put this value in this equation. Now put this value for the second time iteration. This is the first iteration. This is the first iteration. Part B we have done. Part A is there. Creation of equation. Part B now in the second iteration. X2, Y2, Z2. Put this value of 0.2, 0.3, 0.3, 0.3 in this equation. Calculate again until we got same decimal point. X3, Y3, Z3. So I think we need to calculate up to 7 to 8 decimal points. Then only we can got the 3 decimal points thing. Calculate this value. First iteration I have done. First iteration I have done. Calculate second iteration, third iteration, and fourth iteration. So by default, I think this value should be, this is a minus 3. That's why minus 3 upon this would be minus 0.3. Only change we need to do is because of this minus 3, we need to write minus 0.3. Solve up to, I think in this particular problem, we need to calculate up to 9 iterations. 9 iterations is required. Calculate, I will see. We are going to calculate the first, the final solution. The final solution I am expecting here from everybody. This is one of the simplest thing. Just whatever the values calculated, just put in the equation. If your calculator permits and university permits to use or to use the, or you can save the particular formula in a calculator, then you can use that particular thing also. But I don't know about the programming calculator. If it is programmable thing, you should avoid that. If it is allowed, then definitely you can use the equation and put these values. So calculate, take a 10 minutes, maximum 10 minutes you can take. Everybody should solve, put these particular values and calculate the values. I want to see how many people are going to calculate this simplest thing. The simplest thing in a numerical method. Because most of the method, this kind of simplest thing would be there, would be a 2 to 3 questions would be there. That could be the cakewalk for you. 16, 24 marks, that should be, you should get a maximum. You can take x1 also, or at the top also you can consider x1 also. At the top position x1 or x2, you can consider this way also. Either this way or this way. It would be better because x1 value you should not be confused with this particular formula. So consider this one, x1, x2, x3 at the top. So it will be better. So depending on you, how you are going to handle this kind of problem in examination, and which method or which notion particular sign would be compatible, that you should take. I have suggested that at the top position, if you written the right particular number, it will be more appropriate, I think. Nobody has calculated the values. The x1 should be 0.34, 0.2851 and minus 0.505. 9th iteration we required, 9 iteration. 3415. Exact solution should be 2851 and the last minus 5053. 5053. The 9th iteration, these values are going to get. Cross check your values. Even if your value is going to wrong in between, your any calculation is going to wrong, still your solution is going to come correct. If your calculation is not accurate somewhere, still it will correct itself. So auto correction is there because we have started from zero. We have started from a wrong assumption. So by default, it will be a correct one. So how many people are going to get this value? Just raise your hand or write whatever your solution if you obtain. So I need to stop here because I have a meeting at the seminar hall. So we'll see rest part in the next lecture.